Hi there. As promised, I'm making you this supplementary video that's about some of the evaluation metrics we talked about in class today. And I'm going to demonstrate this for you on the labor negotiations dataset. It's a dataset that has two class values, good and bad. Okay, so if I have loaded that dataset and now I go to the classify panel, I set it up for J48 and I run a cross-validation experiment. If I scroll down in the result buffer, as you see here, we're going to be looking at what's in this very bottommost portion of the result buffer that includes the detailed accuracy by class and the confusion matrix. So I want to point out a few things before we look at a different, more graphical representation of these quantities. So the first thing to note is that we have two categories here. We could have any number of categories. This data set has a class value with two possible categories, good and bad. So if we look at the confusion matrix, we have two rows, one for good, one for bad, two columns, same mapping from A and B to bad and good. So A means the same thing for the columns and for the rows, as you see. We have one column and one row for each category. Similarly, when we looked at the detailed accuracy by class, you can see there's a row for each class value, one for bad, one for good, and then the one at the very bottom is average. Okay. So we can see that. And what are the columns that are of interest here? We've got true positive rate, false positive rate, precision, recall, F measure, MCC, ROC area, PRC area, and class. Now we're not going to talk today about MCC, ROC area, or PRC area. We're going to focus specifically on true positive rate, false positive rate, precision, recall, and F measure. Okay, but keep this picture in mind of detailed accuracy by class and the confusion matrix. And again, the reason why we care about breaking out performance by class is because we might get a good percent correct and even a good kappa, which is percent correct adjusted down so that you don't get credit for agreement by chance. Even if you get a good kappa score, there may be categories that you're doing poorly on. So you want to be able to see that broken out by class. Now we talked about how it is that kappa is good because it controls for agreement by chance. We don't get that with precision, recall, F measure. But we have the sort of complementary advantage of breaking out by class. So what we want to do actually is look at both. We want to look at kappa so that we get the overall picture of how we're doing in a way that doesn't unfairly give us credit for agreement by chance. But then we want to look at detailed accuracy by class so we can see if there are any classes we're doing particularly poorly on. Because if some categories are much more important than others, we definitely don't want to feel like, oh, we're doing well because overall we have a good score if the important categories we're doing poorly on. Okay, so now what we're going to do is look at a different representation, a graphical one, to help us get our heads around these things: true positive rate, false positive rate, precision, recall, and F measure. Okay, so here we can see two representations. We have here a Venn diagram that helps us imagine the space of things that can happen in our data. And we also have a different representation to the right, which is just a little bit of a cartoony version of a confusion matrix. Now we have two categories here that we're thinking about: positive, which we're labeling as P, and negative, which we're labeling as N. Why do we have that all of a sudden when we were talking about good and bad? Well, when we talk about precision, recall, F measure, true positive rate, false positive rate, we're always only talking about one category at a time. So we're either talking about good or bad out of the experiment that we just looked at. for each one of those categories, you could think in terms of the positive class, where that category should be assigned, and the negative class, everything else. So let's say I had more than 2 categories. So here I had good and bad, but I might have good, bad, and mediocre. So there are 3, right? So when I'm talking about good, then positive is good and negative is bad and mediocre. I just put everything else together in that negative class. So this positive versus negative can apply to any category. Positive is the category, negative is everything else. Now, if we look at the Venn diagram, we can see graphically how this kind of is spread out over the data set. This rectangle represents the whole data set. And I have 2 circles in the middle of my rectangle. I've got this blue circle on the left, that's A plus B. That's everything that's predicted as positive in the experiment. And then on the right, I have this purple circle that's B plus C. That's everything that's actually positive. And if you look at the overlap, that's the I-shaped region in the middle, that's everything that's the positive class that was predicted as positive. So those are correctly classified. Now, if you look at outside of those circles, we see D. That's everything that's negative that was actually recognized or predicted as negative. So those are correctly classified also. And the incorrectly classified instances are the 2 moon-shaped regions that you see, A and C. Now, we can look at this in terms of the cartoony version of a confusion matrix to the right. There we see, as usual, the rows are how instances are labeled in our data set. So we've got a row for positive, that's all the instances labeled in the data as positive, and a row for negative, that's all of the instances labeled for negative. And the columns represent how those were automatically predicted by a model. So the column labeled P is everything classifier labeled as positive, and N is all that were labeled as negative. So then now you can see A, B, C, and D as their cells in the confusion matrix. These A, B, and C, and D correspond to the same sets of instances that the Venn diagram referred to. So it's really just 2 different graphical representations for the same thing. Now we can see how the different evaluation quantities are defined. We've got precision, which is B divided by A plus B. We've got recall, which is B divided by B plus C, which in this part of the output buffer, where we have this detailed results per category, true positive rate and recall are the same. Now, we will talk about things, there will be places later in the evaluation unit where the relevant notion of true positive rate or proportion of true positives, it's going to be a slightly different notion. But let's not get ahead of ourselves. In the output buffer, where at the bottom, where we have these detailed results per category, when it says recall and true positive rate, it's referring to the same thing. And the reason why those columns are both in there is because some people like to think in terms of precision, recall, and F measure, and other people like to think in terms of true positive rate and false positive rate. So even though true positive rate and recall are essentially the same, for completeness, they put in both sets of quantities that people like to think in terms of. False positive rate is kind of the mirror image of recall. So instead of thinking in terms of those things correctly classified as positive divided by all those things that are actually positive, here we are looking at those things falsely recognized as positive. So those things are negative, but they were predicted as positive. So falsely predicted as positive divided by all of those things that are actually negative, which is the total number of things that you could potentially incorrectly classify as positive. So it's a little bit of a weird notion, but precisely it's A divided by A plus D. Now, what is F measure? Okay, so F measure is the geometric mean of precision and recall. You could just think of it as combining precision and recall so that you're considering them together, and the standard is to weight them equally. There are some times when you care more about one or the other, and so then you wouldn't necessarily compute an F measure in which you are equally valuing both. But here, we're equally valuing both. Okay, so that gives you a definition of precision, recall, F measure, and also true positive rate and false positive rate. You can go to Chapter 5, Section 8 for a little bit more description of this. And we will be talking about all of the evaluation metrics in more detail in the evaluation unit.